Yes, welcome to another class. I don't even know what to call it actually. Should I call it episode? Should I call it series? I don't even know what to call it. But anyways, this time around in this class, what we want to be doing is we want to look at plotting. We want to look at different types of plotting that we have that we can use on AutoCAD as a surveyor mostly, and if the civil guys and maybe architects if they can also learn from it, if it's useful for them, that's fine. So we want to look at plotting. So we have plotting with bearing and distance, like a survey plan or whatever, that you have your bearing and distance that shows the direction. So you want to replot it, or we also have plotting with ray method. Plotting with ray method, whereby you set your instruments on a position and you are able to observe like two, three, four, five, six different points, a lot of points at that same spot, using the same angle and distance to measure. So how you can also plot with that too as well. That is, I call it ray method. So once you're on a point and you are able to pick so many points, so you are using a ray method. And if time permits us, we'll also look at plotting with coordinates. Also plotting with coordinates. That is our easting and northing, our normal easting and northing. Um, you can plot it. The plotting by coordinates, we can plot it manually, like typing it one after the other if you don't have a lot of data like that. Yeah, because I remember when I used to plot with using that manual method, plotting a lot of coordinates, but I've moved from that aspect. So, and you can also plot with that same coordinates by downloading all your data either from Total Station or from DGPS. How to plot those data on AutoCAD, how to download, do your computation and the software that you use so that you can plot them on AutoCAD. So if time permits us in this class, we will look at it together. And if time did not permit us, because I don't like my videos to be too long so that it won't be too boring for you guys to watch till the end. So that's why I'm trying to make it short, short, class by class. So if time permits us, we'll look at the plotting by coordinates too as well. But if time did not permit us, that means we'll do that in the next class. So I just hope you guys watch till the end. So because I tried as much as possible to make sure that my content is natural. So if there are things that come up in my mind, I can share it along the line. So if there are some additions, I can do it along the line. So that's why I always advise that you guys try as much as possible to watch till the end. And if there's anything that is confusing, you can still come back to the comment section box and drop the question there so that I can also attend to it and do a video on it if it is necessary. So let's quickly go into that without wasting our time. So let's quickly go into the plotting with bearing and distance first. Okay, so let me open the survey plan. Let me open this one. Okay, let's use this for example. Let's use this for example. So this is a survey plan. Let's assume I want to replot this, or let's say someone gives me this survey plan that I should replot it, that they need a soft copy of it. So what I will actually do is, it is always good to always georeference, since the survey plan has coordinates, which is the eastern here and the northern here. So that means it has been georeferenced. It's at the right position. And there are sometimes that even the survey plan here on this soft copy might not be at the right position. So what I always do is I will make sure that I start with the coordinate first. But even if you don't want to start with, let's assume there is no coordinate on the survey plan. You just have only this bearing and distance. So all you just need to do is click your line or you click your polyline. I like using polyline. So click your polyline, or don't forget you can always use shortcuts EL, enter. So that is polyline. So you can click on any places, click on a neutral place. Let me click here for example. So once you click a point, it means that you have established a reference point, a starting point. So what you need to do is you start typing your bearing and distance. The first one says, let's open it very well. It says at, so you first type your distance first, which is the formula or the command that AutoCAD recognizes. You have to put in your distance first, then before the bearing. So the command is at. So once you press at, it will show you something like this: specify next point, or so you need to type the distance there, which is 15. So don't forget, this is, I want to choose this point as my starting point because I'm not using the coordinate for a start. So this point is going to serve as my starting point. So I have 15.70 at 15.70. So once you press your distance, the next command is less than. You press less than, then you put the bearing 84. D will serve as degree, then 44 minutes. So let's look at it. You can see, so the first point has been plotted. So I'll go to the second one again, which is at, you press the same command at 29.66 less than 172 degree 48 minutes. That one too has been plotted, so you can see. So let's go to the third one at 15.45 less than 261 degree. Oh, I typed 162, sorry. 261 degree 52 minutes. So you can see that one too is done. So if I can actually close it to this point if I want to. I can close it here, but let's type the last bearing and distance at 30.44 less than 352 degree 21 minutes. So you can see, guys. So you can see that we're having the same shape. So that is how to plot with bearing and distance. And at the same time, so let's input the coordinate first so that we will georeference what we are plotting. So if you want to click your polyline, PL, enter. So this time around, you are going to type, if your survey plan has a coordinate, something like this, if it has a coordinate, so it is good that you start with the coordinates. So we are going to start with easting first. That is what AutoCAD recognize. So you can see, starting with my easting first, 537 415.750, comma. So comma means that you are moving to the next coordinates. Press comma, so to go to the nothing, which is 729,342.960. Press enter. So it will define the point for you. So you can see even this survey plan itself is not georeferenced, it is not on the right place. So this is where the point is supposed to be. Let's confirm again. Let's confirm the coordinates again. PL, enter. 537 415.750. comma, denoting 729.342.960. Enter. So let's see if it's falling. So you can see it's falling in the same place. So that means this plan, this point here, this point here, is supposed to be moved to this axis. So we have georeferenced this place. So what we need to do next is to start typing again. So that is at, what is the distance? This distance is 15.70 less than 84 degree 44 minutes at, what's the next one? 29.66 less than 172 degree 48 minutes. What's the next one? At 15 15.45 less than 261 degree 52 minutes. The last one at 30.44 less than, oh, there's a mistake there. So I need to continue from here. So just go to stretch at 30.44 less than 352 degree 21 minutes. So let's see the result. So you can see here that it's actually the same thing. So that is how to plot with bearing and distance. So it's as easy as that. So you can actually georeference it if you have the coordinates for the eastern and northern. And if you don't, you can just plot it naturally or plot it neutrally like that. So I can actually move this plan now. Let me just move it, highlight, then move. I'll move it to where it's supposed to be. So we're supposed to have something like this. So you can see that everything fits in. So I'll just delete the one I just plotted. So delete this one too. I can save it. So that is how to plot with bearing and distance. So that is as easy as that. Is very, very easy. So I will also be doing how to, I think all these ones are not hard if you know how to use the tools very well. All these roads, designing all these roads, and this one in it are not hard. So let's quickly move to the next one, which is plotting with ray method. Let's look at plotting with ray method. I think I have a feed book already. Let me check. I think I have a feed book. Okay, so let's use this one. Let's use this actually, so we can use it. So if you look at this feed book, you can see. So it's just a feed book that I picked on a site. So I'm on a point. I set my instrument on a point, so I was able to pick 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 points in a place. So let's plot. I want us to plot this now so that we can see the result that we'll have. The Autocad. Let me just maximize it so that we have. Okay, so if you actually want to do this, so what you need to do now is you count all the points you want to plot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 points. So click your polyline, PL, enter. So you can just draw one straight line first. Make sure that this auto mode is on. So draw a perfect straight line like this first, then escape. So this line now, you now have to copy it multiply by the number of points that you have. So we counted 11 the other time. So let us copy, which is CO, enter. So we can copy from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have let me add one more to it just to make it extra. 11, 12. So you escape. So we already have our line. So I can off this one now. Let me bring the picture back. Uh, okay, so what you do next is you can see that the first reason is 0000 degrees, 00 minutes, 00 seconds. So what it actually means is this point serves as your instrument station. So our backside, which is the wall fence, is this. So we actually zero to this angle. We are using this backside as 00. So that's why when I wanted to draw this line, I make sure that I turn on my auto mode to draw a perfect line. So this point is serving as our 00. So what it actually means is once you are rotating your instrument from this angle, let's say for example rotate is RO, enter. So once you rotate from this angle, so you can see that, so it means that once you start rotating your instrument, it will be counting the degree because it has used this point as 00. So it will start counting from here like this: 10, 20, 30, 40, 50, 70, 80, 90, 100, 110, 120, 130, 150, like that back to 360. So that's what this method actually means. So once you've clicked one point like that, so what we're going to do is we're going to plot the next one because we've already have this 00 like that. So we'll leave that like that first. So that is the last one that I'll be doing. So you move to the next one, which is 310. So you type the degree first, 310, compared to the plotting with bearing and distance that we did the other time that we're using at distance less than bearing. This one, you have to start with the bearing first. So we have 310 degree, 16 minutes, 24 seconds. So you can see, so I already have this here. So what I actually used to do is so that I won't be confused by the time I'm plotting it. I always like indicating each line with their reference here. So you can see that this one is wall fence. So I will change this color to, or let me finish plotting it first. So after you've plotted the direction like this, you will type length, which is LEN, enter. So we want to adjust the distance to 15.330. So once you type your length, you press enter, then you right click. You now go to total. Once you click total, it means that you can see specify total length. So we are going to input the length, which is 15.330. We press enter. So once you press enter, you will now select the object you want the distance to have effect on. So we are going to select this. So you can see that the length has reduced. So once we are done with that, I like to change the color. So I always use red for the wall fence or boundary or perimeter fence like that. So that one is done. So we're going to repeat the same process for the next one. We want to rotate this, so type RO, enter, click the same point. So we'll type the next bearing, 307 degree, 14 minutes, 12 seconds, enter. So you can see the angle. So you type length, LEN, so that you can adjust the distance, right click, go to total, then input the distance, 12.285, enter. So you click it. So you can see that one too is also there. So what is the reference? That one is building. So I can actually use blue for this one. I'll use blue to indicate it. So I'll go to the third one. RO to rotate, which is 263 degree, 49 minutes, 28 seconds. Length, click total. So what's the distance? 8.140. 8.140. Enter. So you click on that line. So if you click it at the middle, you can see where it's going to adjust it to. So you must click it at the end point. So that's that. So I'll also change that one to blue as well. Blue. I'll go to the next one. RO. 260 degree, 2607. Length, 26.452. Enter. Click it here. I change that one to blue because it's building. So that is how you repeat everything. That is how you repeat it. So let me quickly fast forward this to the last end. Okay, so guys, this is the last one. So I have the last one here. Let me quickly plot that one. RO, which is this 253 degree, 45 minutes, 0 seconds. So length, go to total, 14.692. Enter. So you click on the line. So that is that. I don't even write anything to it. I think it's wall fence too. So I think it's wall fence. But let me just leave it like this. So this first one that we use as 00, I want to adjust it. That's how I always do. I always do my own work. So you need to find what works for you. So you can adjust your own from the beginning. So but let me adjust it now. So I'll type length. So total. So which is the first one, which is my 00. My 00. So I need to adjust the distance back to the normal, the actual distance. 12.114. Press enter. So I'll click on the line. So you can see. So this is what I have. So my 00 is also wall fence, so I'll change it to red. So now, because I went to site myself, so I know how the site looks like. So it was very easy for me to join. So I'll pick my, let me open it up. So I'll click my polyline PL. So I can join everything up to this place, to this place, to this place, and to this place. So we couldn't have access to this edge, so we pick the wall fence here and here. So I'll use my fillet to join the two edge together. So these are wall fence red. So here, which is building, there's a security house here. So we are able to pick the three edge. So I can easily, because I have the three edge, so I can easily cover this place off, extend, extend. So I have that. And I always like a joined line. Let me send it to back so I can delete this one. So this is my security house. I will make it blue.
So I already have that. So here there's a temporary wall fence here that demarcates this. It's actually here. So can make this also red. Change the width. Is it not polyline? Width 0.1. So I've increased the width. So here I have a building here. Here, no, that's not the edge. And here, so uh, PL. So I want to cover because we could only access the edge, 3 edge of the building. So cover it up, extend, extend. Let me just extend it. I think it was we extend it to the wall fence straight up. That's how it is because there's no access at that place. So that is that. Send it to back. And here, delete this. So I think there's a tiny space there. Yeah, I remember. This one is not supposed to be extended to the wall fence. So this is how the ray method works actually. This is how it works. So this is how the ray method works. So that is it, guys. So I can actually delete this because I don't really need this anymore. So I can delete it. So you can see the final result. So I will just bring in all these stores, copy it so that it looks good. So this is how to plot using ray method. So I can just fill those places up, put my security gate. So this is just a small wall fence that I just used to separate this place. So that's how to plot with ray method. So let's meet in the next class. Let's meet in the next class so that we can discuss plotting with coordinates. So either you input it manually or you download from your AutoCAD and total session, then we do the processing, then we bring it back to AutoCAD so that you can start linking everything together. So thank you guys. Thank you for staying till this time. So let's meet in the next class. Bye.